Ratio, proportion, direct, and joint variations. First of all, let's review what a ratio is. That is a comparison of two values, usually a fraction. And so it's usually like A is to B. That's usually how you read it. Okay, so it usually says A is to B. That's how we read that. A is to B. Okay? A proportion is when you have two ratios set equal to each other. So for example, A is to B as C is to D. So again, we read that A, these are quotes, sorry, A is to B as C is to D. That's how we would read that. A is to B as C is to D. Okay? So how do you solve a proportion? So if I gave you A is to B as C is to D, and I said solve that, I'm sure most of you would say cross multiply. That is the strategy that you learned long ago and use most often, cross multiply. Okay? So let's try one. We're going to try this example. If we are to cross multiply, you take the numerator of one, multiply by the denominator of the other. 3x times 8 is going to be equal to, and then again, numerator of one times denominator of the other. You just make sure that you cross them. 16 times 3. So 3x times 8 is 24x. And 16 times 3 is 48. And then to get x by itself, we're going to divide both sides by 24. And so we get x equals 2. Okay? What do you need to remember about the following problem? 2x is to 8 as 3x plus 1 is to 7. And then solve it. What do we need to remember? We need to remember to use parentheses around any binomials. So, cross multiply. Now we're going to solve it. 2x times 7 equals 8 times 3x plus 1. So you can see right here I used parentheses around the binomial. That is really important. And the reason it's really important is because you're multiplying that whole thing by 8, which means we are going to need to distribute in order to make sure that everything inside that parenthesis, that whole thing gets multiplied by 8. 2x times 7, 14x. 8 times 3x is 24x. And then 8 times 1 is 8. We're going to combine our like terms. So we're going to move or sort all of our x terms. Remember, there's your balance scale. If you subtract 24 from one side, you have to subtract it from the other. So we get negative 10x equals 8. That's a zero pair that canceled. Divide by negative 10. And so we're just going to simplify that. Negative 8/10, both divisible by 2, gives me negative 4/5 as my answer. So don't forget about the parentheses. Okay, that's really, really important. That is just a review of ratios and proportions. Okay, let's start talking about a little bit about direct variation. And you're probably thinking, I don't know what you're talking about. I don't know what direct variation is. When you start looking at it, you're going to say, oh, okay, I know what that is. It's just, this is the fancy name for it. So direct variation, when a number is being compared, and they're directly related. So when numbers are being compared, they're directly related. When numbers being compared are directly related. In other words, example, okay, as 1 increases, the other increases. Or it could be as 1 decreases, the other decreases. Or as 1 increases, the other decreases. They don't have to necessarily both be increasing or decreasing by the same amount. It's just that they're directly related to each other, okay? And so there's all kinds of relations, joint and direct and indirect, and so we'll talk about the specifics between them. But direct variation, 1 increases, the other increases. 1 decreases, the other decreases. These are usually directly related. In other words, they're doing the same thing, usually. So 4 apples cost $1, 8 apples cost $2. This is going up by 4s, so 12 apples is going to be $3, and then 16 apples is going to be $4, okay? The difference between independent variable and dependent variable you will hear often, especially when graphing linear equations and functions, and in things like graphing. When you're reading a graph and you're trying to figure out, like data, you're putting data on a graph, you need to figure out which thing goes on the x-axis and which thing goes on the y-axis. And so we typically try to say that the independent variable doesn't really depend on anything else. It's independent, right? You don't need anyone else if you're independent. It doesn't need anything else. So for example, if I'm going to the store and I'm going to purchase some apples, I know exactly how many apples I want to buy. It doesn't depend on anything else. I can choose to buy as many apples as I want. I can buy 2 apples, I can buy 4 apples, I can buy 12 apples, I can buy 16 apples. Now I know some of you are saying, well, what if they're all out of apples and there's no more apples at the store? Let's just pretend that none of those factors come into play. So the idea is that we're going to go in, we're going to purchase some apples, and the purchase you make on those apples doesn't depend on anything else. What depends and what matters is the cost you're going to pay, and that depends on how many apples you purchase. So the dependable variable is the cost because it depends on how many apples you purchase. Okay, so it's going to depend on how many apples you purchased. And so usually when you're looking at your graph like this, usually the independent goes here on the x-axis. We choose 2 apples, 5 apples, 16 apples, 42 apples, and then up the side on the y is your dependent. That's how much it costs for this many apples, and so it can go up and down depending on what the situation is. Okay, so usually when you're dealing with the graph, your independent is on your x and your dependent is on your y. Okay, so to set up a direct variation problem, here's what you need to do. First, let me clear and scroll the page a little bit so we have a little more room. We first are going to determine the 2 kinds of related data. What are we talking about? Apples and cost? Are we talking about cars and taxes? 2 kinds of related data. We need to figure it out, right? And then we're going to write 1 pair of data as numerators. And we're going to write the other pair of data as the denominators. Okay, and then we are going to solve. And remember, you solve a proportion by cross multiplying. Okay, So let's try this. Example 1. Find the cost of 10 apples if 4 apples cost $1. Okay. So 10 apples, we don't know the cost, so we don't know the cost of 10 apples, but we do know that 4 apples cost $1. So when we say determine, we're talking about, the two things we're talking about are the cost and the apples, and then it says to place some as the numerator and some as the denominator. So I'm going to put apples in the numerator and cost in the denominator, and I'm going to set up my proportion. So 10 apples costs, I don't know how much money, as 4 apples costs $1. So my apples are in the numerator, my apple data and my cost data is in the denominator, and you'll notice that 4 apples cost $1. That makes its own fraction. That is one set of data directly related, and then this is going to be my second fraction. I'm going to cross multiply. So 10 equals x times 4, or 10 equals 4x. Then we're going to divide by 4, and so we're going to get x equals $2.50. So it's going to cost me $2.50 to purchase 10 apples. Okay? How many apples can be purchased with $10? Well, if I know that 4 apples, again, apples in the numerator and cost in the denominator, if I know that 4 apples cost $1, it's asking me how many apples can I purchase with $10. So this time my variable's in the numerator, and again I'm going to cross multiply. So 1 times x is x, and 4 times 10 is 40. So that means that I can purchase 40 apples for $10. And some of you might have been able to do that in your head, and that's totally fine. I just want to make sure that you know how to set these up for the ones that you can't do in your head, okay? Example 2, a truck travels 102 miles on 6 gallons of gas. So we have miles and gallons, okay? 102 miles for 6 gallons is equal to how far will it travel on 30 gallons? So again, don't know how far it's going over 30 gallons. We're going to cross multiply. 6x equals, we need 102 times 30, which gives us 3,060. And then we're going to divide that by 6. And we get x equals 510. So 510 miles is how far we can go on 30 gallons of gas. So that's how you set up direct variation problems. Your two fractions, keep the same kinds of information on the same side of the fraction bar, you're good to go. Let's talk about direct variation with a constant of variation. Essentially, that's what we just did, okay? They gave us 4 apples for $1. In the second example, they gave us 102 miles for every 6 gallons. They're giving you your constant. They're giving you the rate, so to speak. So your constant of variation is defined as the conversion factor. Or you can kind of think about it like the rate. And they kind of give that to you. So your direct variation formula is usually your rate fraction, whatever it happens to be, and then times the one you're trying to solve, right? So you've got, I'm going to try to solve for this x, and I'm going to cross multiply. Your x can either be your numerator or your denominator, depending on what you're trying to solve. And I know that looks really super confusing because you've got same things in the numerator and the denominator, but let's look at these examples and you'll be like, okay, I know what you're talking about. Not so difficult. Unit cost is an example of giving you a constant of variation. So we've given you what the rate is. Find the unit cost, the constant of variation, for a 15-ounce box of cereal that costs $2.29. So if it's $2.29 for every 15 ounces, right, we are going to actually just go ahead and divide that. It's going to give us 0.1527 per ounce. That means for every 1 ounce, it's 15 cents, essentially. So that is the constant of variation. That's the rate. For every single ounce, it's 15 cents. So we're going to use this. Find the better buy. If we have $2.29 for a 15-ounce box, and we have $4.89 for a 36-ounce box, which one is the better buy? So divide them out. We'll divide out the first one. We just did that one. 0.1527. Divide out the second one. We get 0.1358. So 36 ounces for $4.89 is the better buy. It's cheaper per ounce to purchase that one. An architect drawing is scaled at 25 inches for every 5 feet. So there's your constant. It says find the constant of variation. Okay, so that's 0.25 inches for every 5 feet. Okay, so we're going to use that. That's our scale. That's kind of the rate they've given to us. Find the actual measure for 0.75 inches. So again, it's inches over feet. I'll rewrite that for you since I made it look kind of silly. Inches over feet. So 0.25 inches over 5 feet equals 0.75 inches. And we're looking for what is the actual measurement. What is it actually in feet? So we're going to cross multiply. 0.25x equals 5 times 0.75, and we get 0.25x equals 5 times 0.75 is 3.75, and then we're going to divide by 0.25. And x equals 15. So it's actually 15 feet. Find the actual measure for 1.25 inches. Again, this is the solid rate they gave us from the beginning, so we just continue to use it. 0.25 inches over 5 feet. Whoops. Feet equals, and now we have 1.25 inches, and we have to figure out how many feet that is. Okay, so again, cross multiply. 0.25x equals 5 times 1.25. All right, and we're going to end up getting x equals 25 feet. So we end up with 25 feet when we're done. So you go ahead and calculate that, and you should get 25 feet. Okay. Next on our page is joint variation. So we just talked about direct variation. Now we're going to talk about joint variation. Joint variation is when one quantity varies directly as a product. So there's going to be multiplication involved here. As a product of 1, 2, or more others. So solving them, again, we're going to write the steps down, and then we'll go ahead and figure this out. So 1, identify your relationship. And that's important because if it's direct, we cross multiply. If it's a joint variation problem, it's written differently. So that you have to figure out what kind of relationship are you dealing with. Okay. 2, find the constant. So you need to figure out what your K is. Okay, so find constant of variation. Remember, that's the same thing as your rate. And in this particular, in joint variation problems, we call that K. And then you're going to evaluate using K. So using whatever you determined K to be, okay? You're going to evaluate using K with the new information. I know that doesn't make any sense right at the moment, but it will in a second. And so how do you read these? These are read a little funky, right? So if it says y equals kxz, here's how you read it. It says y varies jointly, or sometimes it just says y varies as x and z. Okay, x and z. So I want you to think about this. Y varies. This automatically means you're going to have y varies. If there's varying in any way, you're going to have a k. So this varies is your equals k. So y varies, and then as is kind of your hint that it's multiplication. Okay? And what are you multiplying? X and z. So I want you to think about that as we read these and try to solve them. So W varies. Oh, that means W varies. Okay. As means multiplication. What am I multiplying? X and Y. So there's my equation. So you read it, and then you kind of write your equation as you're reading it. W varies jointly as X and Y. Jointly means multiplying, right? And varies means equals K. So I have W equals K, and I'm multiplying X and Y, okay? So what we have to do is, they're going to give us some information. In this case, they give us X, they give us Y, and they also give us our joint variation, which is our K. So when we read our directions, we've got our relationship, we wrote our equation, that's step 1. Step 2, find the constant of variation. Lucky for us, it's given to us in this particular problem. And step 3 will be to evaluate. And so now, all I'm going to do is plug in what I know. K is 0.5. X is 140, and Y is 6. And I'm just going to go ahead and multiply, 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 and I get W is 420. Okay, that's the first example where they give you the joint variation, okay? In the second example, so maybe we should write over here, gives K, all right? When they don't give K, here's what you do. Okay, where they don't give K. So I'm going to scroll the page up, and then we're going to go ahead and try the second one where we're not given K. So now I don't have K from the beginning. Here's what I have to do. Write your equation. Simple interest for an account is jointly proportional. So interest is jointly proportional to the principal and the time. So when you're dealing with money, this K is usually written as R for rate. And you'll remember I equals PRT. That's kind of your constant equation for finding interest, okay? So I'm just going to rewrite it. So it says I equals PRT. That's our interest formula. R is where we put our K. Same thing. If you want to use KPT, you certainly can, and it's easier, I think, sometimes to do that. I equals KPT. Now let's see what we have. If the quarterly interest for an account balance is this, so that's the interest, okay? The balance is this. If the quarterly interest is $87.50, that's your interest, that's your principal, that's what you started with. Find the interest on the balance of, again, this is the principal, and you're looking for the interest, you don't know it, over 9 months. So that's a lot of information. Here's what I'm going to ask you to do. I like to color code usually when I'm reading these because it makes it a lot easier. If you start with the if and you underline it all the way to the comma and then you stop there, that's going to be your first equation, okay? And then if you start at the comma and you read all the way to the end of the sentence, that's going to be the second time that you use your equation. Now you're thinking, I don't know what she's talking about. Okay. So what I like to tell students is when you do not have your k, when you have no idea what k is, write the equation twice. And in the first equation, we're going to find k. And we use that first part underlined in blue to help us find k. So it says if the quarterly interest, right? So quarterly interest means how many times a year if it's quarterly. 4 times a year, so that's a quarter, or 0.25. You always have to put the time in, and it's always measured by the year. So if it says quarterly, that's 1/4, and 1/4 is 0.25, okay? So if the quarterly interest for an account balance of $7,000, that was the balance, that means that's the principal. That's what you start with. That's how much you put in there. So you put $7,000 in for every quarter, and the interest you made was $87.50. We want to know what K is. We don't know what the rate is. I know how much interest I made, I know how much money I started with, and I know how long it was in there, but I don't know what the rate was. So I'm not going to be able to figure the interest balance on $8,500 for 9 months if I don't know what the rate is. So I'm going to find it by using this formula. 8750 equals K times, I'm going to do 7,000 times 0.25. And I'm going to get my number, whatever it happens to be. I don't know what it is. I didn't calculate it. But you're going to take that, get your number, then you're going to divide by it to get K by itself. Okay, divide by that number, get K all by itself. And in this case, it is 0.05. So I'm going to give you a minute to do 7,000 times 0.25, and then divide both sides by that number and see if you get 0.025. Then what you do, you could pause the video and do that and then come back. So then what you do is use the second equation, the K you just used or just figured out. I finally know what my interest rate is. I'm going to plug that in. It's 5%, or 0.05. The balance that I put in this time was $8,500, and I put it in there for 9 months. So you have to do 9 divided by 12. Right? And that's 3/4 of a year. 9 divided by 12. And so that's 0.75. And then you're going to just go ahead and multiply and figure the interest. We would not have been able to do the interest before if we hadn't figured out what K was. So use the first half of the equation to figure out what K is, and then you use the second half of the equation to actually solve what it's asking you to solve in that second half. The interest, once you figure it, hopefully if you do it correctly, you're going to get $318.75 is the interest that was made. That would be your answer to the problem. So there's a lot going on when they don't give us K. We will practice that multiple times in class. Note the similarity between joint variation model and simple interest formula. I'm hoping you're understanding the difference. Remember I said I equals PRT is usually the simple interest formula, and the rate is the same thing as the K. That's really what we're hoping you to see. R equals rate, and K is also rate. You can use either one, R or K, in your equations. I'm fine with both.